So now today let's go to continue with our lecture about the loops. Okay, I'm going to talk more examples, and more, especially towards the end, we're going to talk about how we can have nested loop. In which case you're running a loop inside another loop, and there's a reason for doing this. And for your lab number 6, which I will release eventually, lab number 6 is really about to really build a particular app where the underlying data structure is not just one-dimensional array. It's going to be a two-dimensional array. So that's going to be more exciting to program about. But we'll get there hopefully today. If not, then definitely next Monday. Okay? So now, let me just have a very quick summary. So this is something you're really expected to have grasped already from last time. Let me just review that very quickly. In general, if you're given an array of elements, let me talk about the problems first, and then we have to talk about how to solve these problems, because they might just occur in your lab test later. Let me just say add page below. Okay, so what kind of problem are we trying to solve? Let's say the input is simply an array of elements. Array of elements. What can that be? It can be an array of integer, or it can be an array of string, for example, or it can be an array of Boolean. So that's kind of the input we are dealing with. But what's really the problem we are trying to solve? There are two kinds of problems we are trying to solve over here. And then we'll think about some boundary cases in just a moment. So the problem we are trying to solve is, there are two kinds of problems. The first kind is, are all elements in the array, or all elements in array, let's say A. Okay, let me just say array A. So that's the input. Okay, that's the input over here. Are all elements in array A satisfied with a property? That's the first kind of problem. What about the second kind? The second is there at least an elements satisfy an elements in A, of course. In A, satisfy with a property. So I'm going to highlight the thing you should really pay attention to. So one is all, right? That's one kind. The other one is at least one. So these are the two kinds of problems. Let me give you one example right away. Okay? So now what can the property be over here? So the property over here, you can see a property over here and property. So property here is a very general concept. Anything that can be evaluated on the elements of your array and return either true or false is a property. Any Boolean condition. For example, in the case where you have an integer array, it can be all positive, right? It's about being positive. Okay? You want to see if are there all the elements in the array positive, or is there at least one element in your integer array that's positive, right? So property can be anything. What about string? You can say the simplest one would be, let's say equal to a particular string, for example, A. We want to see how if all the elements in this particular string array are all A's, or there's at least one string in the array that's A. Okay? Let's see one example here. Let me just take this particular example over here and then show you. Okay, let's say we talk about the positive being the property, okay? So that's a property we're talking about. So now let's say for this one over here, so let's say we have an array over here. Let's say that's an input. Let me just put the input maybe above over here. That's easier for you to see. Input over here. So let's say for the same input array, and then we got indices 0, 1, 2, 3, 4. And then what about the elements? They are simply integer array. So let's say 3, 2, minus 1, 2, and 6. Okay, that's an integer array. So now for problem number 1, we're asking if all the elements in this particular array satisfy this particular property, which is about each element being positive or not. In that case, that should return false, because we can find that over here, you can see this is minus 1, which tells you that there's at least one element that violates the property. And if you have followed along the video solution to lab test preparation example, so this is, let me just show it to you. Over here, this is so-called the witness. The witness of violation. Okay? So what does witness of violation mean? That means for problem number 1, as long as you can find out at least one element in the array that does not satisfy the property, that means for this one, you got to return false. Return false. If a, let's say witness of violation, I would say witness of violation. Okay, let me just write it out, otherwise you'll be confused. If a witness of violation is found. Okay? That means once you find out there's at least one element that violates the property, which means we'll make the property false, return false right away. Okay? What about the second one? The second one over here is to say we want to find out if there's at least one element in the array that will satisfy the property. In this case, the witness we are trying to find is kind of the opposite, logically the opposite. So now, if I ask you for this, the same input array, is it the case that at least one element in the array is positive? True. How can we find the witness? In this case, I'm just going to use a different color over here to show you. This is, for example, the first element is already positive. So there's at least one element that's positive. So now in this case, how do we call that? For this one over here, we say that is witness of satisfaction. Okay, so now that means for problem number 2, we should return true if a witness of satisfaction is found. Okay, you can try to see that in the two cases, the boundary cases are kind of symmetric. You can see for one of them is actually returning false, the other one returning true. Okay, and one is to find a witness of violation, the other one to find a witness of satisfaction. Okay, but conceptually, does it make sense to you so far? Right? So now the property over here can be any property, as long as it's going to be returning true or false on each of the elements. For example, in your preparation test, it's multiples of 5, which you can also encode as a Boolean expression. You can say the element modulo 5 equals 0. That's also going to be Boolean. So I'm just talking about more general structure for the problems. So in the lab test or in the exam, I can give you any kind of the property that can be evaluated either true or false. But the way you do that, the structure is really the same. Okay. Any questions so far? So the term you should really know is the witness of violation over here, and also the witness for satisfaction. And in the case of number 1, you're going to return false if you find a violation case. As soon as you find out one, it's going to return false. For problem number 2, as soon as you find out some satisfaction case as the witness, you should return true right away. It doesn't matter what the remaining of the array is. So now, carrying on with this kind of logic over here, we have some special cases for you to worry about. And hopefully after this kind of logic over here, we can now think about the special cases. Okay, let me put it here. Okay, that's all the space we need. Now think about what if the input, we say that it's an array of elements. What if the array is empty? Okay, let's say input over here, empty array. Okay, and then now tell me something. We're going to consider for problem number 1 and for problem number 2. Okay, for problem number 1, we're asking the following question. Are all the elements in the empty array satisfying this particular property? For example, all elements being positive. And for the second one, we're asking the following question. Is there at least one element in the empty array such that the element is satisfying the property, for example, larger than 0? Okay? So now think about for the empty array case, should it be true or false? Or you don't know, which means undetermined. Okay? It turns out, for number 1 over here, let's try to carry on the logic. Okay? Let's say for number 1 over here, basically, as we said before, it's going to return false. It's going to return false as soon as we can find out some witness of violation. Now, in the empty array, can we ever find a witness of violation? We cannot, because there's simply no witnesses in the empty array. There's nothing there. Okay? So for number 1, it's going to return true. Because there's no witness of violation. Okay, that's how the logic goes. Since you cannot find anything to prove that the property is wrong, so it's got to be true. Okay, and then I will try to, for those of you who took 1019 or is taking 1019, I'll relate this to some logical properties for you. Okay, I'll do that in a moment. But what about number 2 over here? So we try to apply the similar logic as we said in line number 2 over here. We say that as soon as we can return true as soon as we find out there's at least one witness of satisfaction. Now in this case, can we find any witness of satisfaction? We cannot. So that means this must be false. Because we cannot find any witness of satisfaction. Okay? So you can see that in the case of the empty array, depending on which category of problem you're solving, for the first kind, it's going to return true. And for the second kind, it's going to return false. Of course, you don't just memorize it. There's a logical reason behind that. Okay? So now, for those of you who has taken 1019, it's taking 1019, I want to draw some logical property for you, just to relate, which is something that I'm pretty sure if you took the course, you must have learned. Okay? So now, we know that this is so-called the Forall operator, right? We know that this is there exists operator. So this is exactly what the first kind of problem is solving, and this is what the second kind of problem is solving. Okay? So now we say that for every x, any variable, such that if I say x is a member of empty set, you can think about empty sets like empty array. Okay? Now, it is the case that any property that I can apply to x. Okay? On the other hand, I can say there exists at least one x such that x is in the elements of empty set, and then in this case, it's going to be p of x. Okay? So now if you try to relate back to your logic course, and we know that, of course, first of all, we know that there's nothing that will exist in the empty set ever. So this is always false, which means the range is empty. The range is simply false. And then over here, overall, since we cannot find any witness of violation, so it's going to be true. Okay? That's what you learn from the logic course. On the other hand, this is going to be false because we cannot find any witness of satisfaction. Okay? Any question about this logically? Okay? If you haven't taken 1019 before, and don't worry too much about these symbols. I'm just trying to draw a connection. Since quite a good number of people has taken that course already. But this is more important for you to know. Okay? So in this slide, I'm simply summarizing what does it really mean to be empty array for the two cases. You should really know both. Okay? Any questions until now? Are we okay? Yeah. This one? Yeah, so I'm just trying to say intuitively over here. To be honest, this is more like an axiom, which means something we take it for granted. I'm just trying to explain to you the intuition behind. So when you say for all over here, you're trying to say, in the case of programming, you're trying to say for every element that I can iterate through in the array. But now in this case, we're saying that it is the empty array that we are talking about, which means nothing you're going to iterate through. In which case, you can never find out anything to prove that the property is wrong. So that means the property must be true. Similarly, in the second one, since when I iterate through the array, nothing can be iterated through. So that means I can never find out anything to prove that this is true. That means it must be false. That kind of intuition behind. Yeah. Hey, now, guys, are we okay so far? Okay, I will relate this back to the code in just a moment. Okay, so now let me just go back here. I want you to pay attention to this particular line over here. Can you look at line number 2 for me? Remember what the product was when we went through this particular slides. We say that we want to check to see, given an array of numbers is like an array of the input. We want to see if all the elements are positive. So that's the first category of problem we are trying to solve, right? And the reason that I'm trying to initialize this Boolean variable to be true, one way to see it is to think about, so far, I have not iterated through anything. It's as if I have iterated through an empty array, in which case, I have not found any violation witness to prove that the property is wrong. So that's why it should be true, okay? You will see that later on for another example. Let's say I change the problem just a little bit like this. I say that given an array of numbers, determine if it contains at least one positive numbers. In this case, how should I change the code? The way I change the code is like this. First of all, if I'm trying to solve the second kind of problem, which means there's at least one element satisfying the property, in that case, the initial value would be false, which means so far I have not found any satisfaction case yet. So that would be false. And then inside the loop, I'm going to say, rather than trying to do conjunction, I'll use disjunction. Let me just use this one here. This might be easier. You know, I mean, right on the iPad. That'll be easier for you to see. Okay? It's really important for you to see this. Okay, let's see the different kind of problem. Let's say, if I say problem number 1, all numbers are positive. Okay? The most naive way to do this would be, I can say some Boolean. I'll say the result so far. And then we know that it should be false, oh sorry, true. Okay, empty array will be true. And then we say for integer I is assigned to 0, I less than, let's say input is array A dot length. And then I plus plus. And then over here, we're going to accumulate a result, you know, between each iteration. So we say so far is assigned to so far conjunction with, right? We're going to say every element, this element is satisfy the property, and the next one also satisfy the property. And we say array of position I is larger than 0. Okay, that's the first problem. So what I want to highlight to you is, you can see that over here, you can see, let me use maybe blue to show you. The critical thing is, you can see that this is true, and also we are using conjunction. Okay, let me now change the problem. If I change the problem to as follows, at least one number is positive. Now, what should I change? Exactly where I highlighted. What I should do is, so far, if so far means I have only read an empty array so far, that means I have not found any satisfaction witness just yet. So what I will put is, I'll put false over here. And then I'm going to try to see either this element is positive, or the second element is positive, or the third element is positive, or, you know, etc. So that means I will use disjunction instead, right? That's how I switch between solving the two kinds of problem. So now in this case, I'll put false versus disjunction, right? It's just a summary of what we have covered, okay? Again, it really relates to the more general structure for the two problems over here. The property I give to you will be arbitrary, but they must be Boolean. So that's why you should really know how to set up the boundary cases and how you can understand why the rationale is behind. Any questions about this? Yes? Okay. Yeah, well, of course, apparently you can see that, yes, one is true, the other one is false. But you don't want to really understand the regular reverse. You want to understand what's really the rationale behind, what's the intuition. Why one case is true, why the other case is false. Of course, you never memorize this, because you memorize to the wrong thing, then it's not going to work, right? Yeah.
So, is I calculating the true values?
We're going to accumulate the value, okay? Guys, let me ask you one more thing. How about that? Let's try to be a little bit more scientific. Let's say we don't really trust on this particular value. Let's say let's just take this one for example for you. Let's say I want to take this for the example over here. So I'll do another slide for you. Okay. Let's think about what if somehow you memorize wrong. Okay. Let's say we still try to solve the first problem over there. So now let's think about this. Let's say over here, let's say all numbers positive. Okay, let me just put the code again. So I would say Boolean so far. So now let's say rather than being true, I'm going to put something that may not work. Let me put false. How about that? Okay, and the rest is going to be the same. I'm still going to use conjunction over here. Okay, so I'll say for integer I is assigned to 0, I less than input array a, the length, and then I plus plus. And then over here, I'm still going to use conjunction. I'm going to say so far is going to be reassigned to so far. Conjunction with a at position I is greater than 0. Okay, so you can see that over here, these are the two critical things: false and also conjunction. Now, is this going to work ever? Let's think about why if it doesn't work. Let's put an array over here. If you put an array over here, let's say this array. Let me put something very short. 0, 1, 2, 3. And then what about the elements simply, let's say 3, 4, 5, and 6. Apparently the result for this one, all positive, should be true. However, is it really going to return true, right? Now, thinking this way, what we are trying to, conceptually, this is what we are trying to do. For the first iteration, what we will do, let's say, let me try to use this one to illustrate to you. Let's try to use over here, a table over here. Initially, I is simply equal to 0. Okay? In this case, so far, at the moment is the initial value false. Okay? And then for the very first iteration, I is 0, so we're considering position 0. In that case, AI larger than 0 is basically doing 3 is larger than 0. We know that this should be true. But now the problem is, let me just call this maybe L. Let's say accumulation, acute. Okay? What about the accumulation part? Basically, we're accumulating to say even though this is true over here, but so far was initialized to be false. So true and false will give you false. In fact, remember that we learned a little bit about logic. For conjunction, as long as one side is actually false, doesn't matter what the other side is. So now even though this expression over here for the very first time is actually true, but it's going to give you false because the initial value for so far on the left-hand side is actually false. So it's going to give you false. But do you ever get a chance to return back to true though? You never get a chance actually. Let's just try another iteration over here. Let's say we try to do I is incremented to 1. And then we know that so far has been the conjunction for false and true over here, so that will be still false. So now, let's say now I is equal to 1. So now we are considering this particular element over here, AI. Okay? Now AI is actually false, 4. So we are comparing 4 larger than 0. We know that it is true. However, what's the accumulated value, the latest one for so far? It's still false. So that means we still get false over here. So you never get back. To make it a little bit more, even more explicit for you, what we are trying to do is like this. We know that for this particular array, for all the elements to satisfy the property, we need the following. We want A0 to be larger than 0 and A1 to be larger than 0 and A2 to be larger than 0 and also A3 to be larger than 0. That's what we need, right? But now the thing is, we want to accumulate it into some value, which is the initial value for so far. If so far is simply just false over here, and you try to accumulate. If you do that, what you will get is, this one, for the very first iteration, is going to be false. Okay, and then for this one over here, for the second iteration, false and true is also going to give you false, and etc. You never get a chance to actually go back. Okay, so that's why this is wrong. It should be true. Okay, so you should really try to struggle yourself a little bit with how we chose the initial values. If you choose the other one, why it wouldn't work? Okay, as symmetrically, you can also try to say, for the case of the at least one element satisfy the property, the correct value should be false. But what if I put it as true? And the same logic should really apply. You should really try to follow the same manner of reasoning. Okay. So now in the test, it might be that I might just give you the wrong initial value over here. So don't assume whatever I give to you will be correct. You have to really try to trace the program to see how it works. Okay. It's kind of a tricky example, but that's exactly why we're here to discuss. Any questions? Are we okay? Okay. Huh? Let's talk about it later, not now. Okay. Don't divert. Okay. Okay, guys, are we okay? Any questions? Okay. Okay, let's now go back to the slides very quickly. Okay, so now we can just go back to where we were, and then you should be able to follow many of the slides, and then I'll just tell you. So these are the 4 versions that we talked about last time. And then for version number 2, you should really know why it doesn't work. So it's already explained details from the last week's lecture. You should refer to them. Okay, so this one over here is about how you can calculate for maximum value. Okay, let me just talk about the idea very quickly, because that's one of the question for your practice test. This is how you can think of it. So that's the code already. You can study the code. The intuition is very easy. Let's say if I got an array like this. Okay, let me just use the same example as in the slides. Let me just put it here first. 2, 1, and then 3, 4, minus 4, and then also 10. So now the idea is very easy. We started with something over here to say max is initially just the first elements. Okay, so we have some variable over here called max. And then we say that it's simply just the very first element in the array. So let me just put indices over here. So 0, 1, 2, 3, 4, 5. So now we're saying that max is simply this element here, just to begin with. And inside the loop, you're going to do some selection over here. The selection is, if the current element you're looking at, because we actually we keep incrementing loop counter from 0 until array.length minus 1, right? So now this is the array A. Okay, so A.length over here is simply 6, right? So the last index we'll look at will be 5. So every time when we look at a particular element, if the element itself is larger than, strictly larger than, the current maximum we are trying to maintain, that means we're going to override it. For example, let's say over here, in the first iteration, let me just draw some table over here to show you. When I is equal to 0, that means the very first iteration. In this case, we are basically comparing, so now ai strictly larger than max. The first iteration is kind of interesting. You can see that since we initialized the max to be the first elements anyway, so now basically what we are trying to do is we are saying A0, which is 2, larger than the current maximum, which is 2. So that will be false. False simply means we don't have to update the maximum just yet. We don't have to. Okay. Now what about we go to the second iteration? Second iteration, I would be 1. In that case, A1 would be 1. 1 larger than the current maximum, which is 2. False. So we don't have to update. What about we go to the next one? When I is incremented to 2, in that case, A2 would be 3 over here. So we are doing 3 strictly larger than 2. In this case, it is true. So what does true here really means? That means we have to update the current element we are looking at to be the current maximum. You got to do that step. So now that means we're going to update this 2 over here to be 3. So actually, so far, we're thinking this way. After the first iteration, we have scanned through. Let me thinking this way. After the first iteration, we have scanned this part of the array so far, only this part. After the second iteration, we have scanned through the array up to now. After the third iteration, we have scanned through the array up to now, over here. And up to now, we only have scanned through 2, 1, and 3. What's the maximum? 3. Okay? So every time when you want to do one more iteration, it's like expanding the yellow area by 1 element. Okay? So now, the next iteration there, if we try to do another one, let's say we try to do, let's say I is incremented to 3. In that case, should we update? That's a question. So now, in that case, A3 is over here, which is 4. And 4 larger than 3 is true. That means at the moment we should really update the maximum again. Okay? So that means after this particular iteration, we have scanned through the array this far. Okay? And then the maximum, we should update that from 3 to 4. Okay, so eventually, once you have scanned through all the array, you will actually scan through the whole thing up to now, right? Up to now, over here. So the total maximum will be 10, because you can see that 10 over here will actually be larger than all the previous elements, okay? It's a very simple example, but it's really also important for you to see why we are doing this way. The intuition behind this, we try to give some temporary answer over here to begin with. And then every time after a particular iteration, we try to update the result when necessary, okay? Which means the current elements is strictly larger than the current maximum so far, okay? So now you should really think about the following question. What if I change the problem to be, rather than finding the maximum for the array, what about I want to find out the minimum of the array, okay? In that case, what should I do? The minimum of the array. So now we should really think about, we still have to scan through the entire array, one element by one element, but the way we update the current minimum will be a little bit different. Rather than saying the current element is strictly larger than the current minimum, we should say the current element is strictly less than the current minimum, and then we update, right? So now, as an exercise for you, okay, should be easy to do, exercise for you. Find minimum. Of course, in your preparation test, I gave you something even more challenging. Find out the second maximum, right? Of course, a very easy way to do it would be, for those of you who know about Java array classes, you can say arrays dot sort A, and then after that, you can simply go to whatever A being sorted is and go to A1. Beyond this course, you can do that maybe for your own projects, but for this course, no. If I give you this in the test, you cannot do it that way. You cannot use any Java library. You must use just primitive array and also loops and if statement to program, okay? Just to mention that. Okay, okay, that's about this example here. Okay, let's try to go on. Question for you. The first question, I already said that, okay? What about second question? Will the program still work if we change the initialization in line number 2 to I is assigned to 1? Oh, sorry, integer I is assigned to 1. Sorry, what I meant to do is this one here, okay? Let me say that again. The question is, let's say over here, maximum is assigned to A0. Let's say I don't want to do this. I want to do the following. Let's say rather than saying this is, rather than saying max is line number 1, I'm talking about, is assigned to A0. I want to say rather than this, what about just assigned to 0? Is this going to work? That's a question for you. If it is not going to work, can you give me a case where it doesn't work? I simply say 0. Yes. Yeah, I'm just saying that, so now the temporary maximum, I just set it to be 0 rather than the first elements. So would it work? Will still not work. Would it work? Or So in that case, it doesn't work, right? Okay, exactly. So the answer is no, it wouldn't work. No, it didn't work because array may contain all negative. I'll show it to you very quickly. Okay, so now let me just draw that just here very quickly. Okay, let's say over here, let's say we just got 3 elements in the array. Let's say we got -2, we got -3, we got -1. Conceptually, what should be the maximum in this case? -1, right? -1 should be the maximum. But now, if we actually apply this particular initialization here to say max is assigned to 0, so that means we will never be able to satisfy this condition over here. Because for A0, -2 larger than 0 is false. For integer 1, -3 larger than 0 is also false. And for the third element, -1 larger than 0 is also false. So you never get a chance to override it. So be careful. Okay? So now that's why it doesn't work. Okay? That's a subtle thing to really realize that doesn't work. Okay? Okay, that's good. Okay, you can also search through the tracing over here. I'll leave it to you. That's basically how I traced it before. Okay, this one over here is about, let's try to read the problems together, and then I'll just illustrate to you again the intuition. You got exactly the same problem here for your practice test. Okay, given an array of integers, how do you determine if it is sorted in a non-decreasing order? There's some terminology I would like to illustrate to you very quickly. So now, in computer science, there's a particular problem called sorting, which we'll talk more about possibly in 2030 and 2011 later. But now, let me just explain the terminology to you. You got something called ascending order, non-ascending order. Also, you have something called descending. Also, you have non-descending order. Yeah, sometimes for ascending, the more informal way of saying that ascending is increasing. Okay, basically the same meaning. Increasing, and also for descending, sometimes people say decreasing. Okay, so now we want to know what they really mean. I'll give you an example. Ascending over here is very easy. That means when you go along the array from left to right, you must be strictly increasing. For example, so now if I say 1, 3, 5, 6, 7, and 8, this is okay. Oh, sorry, this is okay. Okay, this is fine. What cannot be fine? If I say 1, 3, 3, 4, 4, 5, this is not good, because if you look at the number over here, 3 and 3, and also 4 and 4, for you to go from 3 to 3, you don't really increase the level. You just go at the same level, basically. Okay, so that means if you actually got a relation like this, less than, less than, less than, less than, that's exactly what ascending really means. Okay. On the other hand, if you got anything like a less than or equal to, it does not satisfy the ascending property. Okay. Now, what about non-ascending? Non-ascending. It's easy to understand. Non-ascending simply, when you say none, that means the negation of something. So when you say non-ascending, that means it is not the case that it is ascending. So we say that before. Ascending simply means this particular relation over here, strictly less than. And we talk about in the logical laws, what does it mean to be the negation of less than? Non-ascending. That means less than or equal to, right? Larger than or equal to, right? Non-ascending. Okay, let me just write something here for you. So now if you got 1, so let me say A, so we're gonna go the other way, okay? But the other two are very symmetric. Let me just do it this way. So let's say 8, 7, 6, 5, 3, and 1. That's one example over here. And also you have 5, 4, 4, 3, 3, and 1. Okay, so non-ascending over here is pretty much like the negation of ascending, which is this relation over here. So that's equivalent to something larger than or equal to something, right? We have satisfying this. So that means A larger than or equal to 7, 7 larger than or equal to 6, 6 larger than or equal to 5, and etc. So this is okay. Similarly, this is also fine, right? Okay, that's fine. Any questions about this? So that's kind of the terminology we really get used to. So in the test, I might simply just give you the terms over here, and you should know what they really mean. Okay? Okay, so let's go further. So now, non-decreasing. What's non-decreasing? That means, what's decreasing? Decreasing means, let me just go back here, non-decreasing. Okay? Decreasing simply means you should really go strictly lower, right, for between every element. Decreasing simply means that. Okay, let me just, for completeness. So let me just draw some separator over here so you can see. So now this is only for this section over here. And this is for this section over here. Okay. What about decreasing? For decreasing, let's see example over here. So if you got 8, 7, 6, 5, 3, and 1 versus 5, 4, 4, 3, 3, and 1. When you say decreasing, that means this later number must be strictly less than the other one. Like that. Okay? It is the case, it is the case, it is the case, it is the case. So this is decreasing. We'll go strictly decreasing. Okay? What about the second example here? Is that decreasing? No, it is not. Because you can see from 4 to 4, when you say this, it's not the case. Right? So this is not decreasing. So now what about non-decreasing? When you got non-decreasing over here, let's try that. When you say non-decreasing, that's exactly the opposite, right? So now, if you try 1, and 3, and 5, and 6, and 7, and 8. 1, 3, 3, 4, 4, 5. Let's think about what non-decreasing really means. Okay, let me just, so non-decreasing. So non-decreasing over here, we know that decreasing simply means the decreasing is like this. The earlier number is strictly larger than the later number. Okay, so now that's what we have. So some earlier number is strictly larger than the later number. Okay, but since we say none, put a negation before that. So that means we got the earlier number less than or equal to the later number. Okay, so now do we satisfy that over here? Yes, we do. Okay, similarly, do we also satisfy that? Yes, we do, because you can see 3 and 3 is an equal case. Okay, and that's also fine. So these are the 4 terminologies you should really try to get used to. Okay, so now let's go back there. When we have over here non-decreasing order, that means for every element, we want to make sure the earlier number is less than or equal to the later number. Okay, but now how do we do that? Okay, conceptually, this is how you do it. Okay, so now let's do that. Just do one example here. So now let's give you one example where it should return true, another example it should return false. Okay, let's say this: 3, 4, 4, 5, 6. Another one, let's say 3, 4, 4, 3, 6. Okay, so now we can see that the way to do this is like this conceptually. We want to compare for every pair of adjacent positions in the array. For example, starting from this pair, We want to make sure 3 is less than or equal to 4. It is the case. And then the next pair to compare would be this pair over here, right? 4 is less than or equal to 4. And then 4 is less than or equal to 5, which is the case. And then 5 is less than or equal to 6. Can you see that? Okay, let me try to do a little bit better. Okay, the first iteration there, we want to make sure 3 is less than or equal to 4. For the second iteration there, we're going to make sure 4 is less than or equal to 4. Right? And then we're going to do another one. And then 4 is less than or equal to 5. And then we'll do once more. And then we do 5 is less than or equal to 6. Right? So we want to make sure we check for every adjacent indices. Okay? So now you can see that it's satisfied for all the adjacent indices. Okay? But what about this one here? First iteration, first 3 less than or equal to 4, that's okay. And second iteration, 4 less than or equal to 4, that's also fine. However, when you do the third iteration, 4 less than or equal to 3, this is violation. So this is violation. Because 4 less than or equal to 3 is false. So that's not good. Okay. So now how do we generate this into a loop? The idea is very simple. You can think about what indices are we comparing? Let's think about that. If you got indices 0, 1, 2, 3, and 4. For the very first iteration, we are trying to compare A0 less than or equal to A1. For the second iteration, we do A1 less than or equal to A2. The third iteration, A2 is less than or equal to A3. And then A3 is less than or equal to A4. Now the question is, what should be the upper bound for the loop counter in this case? Should it be A.length minus 1? No. Because if it was A.length minus 1, that means we still get A4 less than or equal to A5. Now in this case, you got array index out of bounds exception, right? That is why you will see exactly over here. That's really the highlights for this particular example. Okay? Since we are really trying to do the following, we simply say, since we know that we're going to follow the same pattern over here, 0, 1, 2, 3. So that's exactly loop counter I. So that's loop counter I from 0 to A.length minus 2, okay, rather than minus 1. And then since we're going to say, and what about here, over here, accordingly? I plus 1. Okay? For the Fibonacci sequence example, which I talk about in the example, you will see something like this. You have to be a little bit careful with where you start or where you end. Okay? Any question about this? So the main highlight is, you can see that we are solving the first category of problem again. So we initialize the value to be true. That means initially we haven't scanned through any part of the array, it's like empty array. So we haven't found any violation case just yet. So that's why initial value should be true. And then also the loop counter exit condition over here. And also we're using in conjunction. Yeah, David first. Yeah, sure. So let's say hypothetically, can we try this? The question was, let's say for this condition over here, let me just put it here. What if we just do what we used to do? We say I is strictly less than A.length. Okay? Now, to see this, you really want to see what's really the indices that we are using in the body of the loop. You can see that over here. Let's try to highlight that. So we say AI is less than or equal to AI plus 1. Right? Okay, now, if we simply go with this normal way of state condition over here, so that means the first value for I is going to be 0, right? And second value of I will be 1. What will be the last value of I? In this case, let's say this is the array. What will be the last value of I? 4, right? Okay, so we got 0, 1, 2, 3, 4. So now, when you get to the fifth iteration, which we shouldn't get into, what you will get is, you can see that 4 over here is I, and then we got I plus 1 would be 5. And 5 is exactly a.length, right? Which is an invalid index for this, okay? Be careful, okay? Okay, questions? Are we okay? Okay. If you want to see more logic about how to go through the code, also is in the video. You can also see that for this particular example. Okay, this one's done. Okay, just one more thing to show you. You can see the second version I show you over here is to say that, so now there's a second version over there. You can see in the first version over here, I'll say version 1. Version 1, scan entire array. Okay. You know what? Let me just compare for you. So this is version 2. This is version 2. Let's just put version 1 over here again very quickly. Version 1 over here, we also say Boolean is sorted, is assigned to true, the same as line number 1. Now, for integer, I is assigned to 0, and then you can see the critical difference is over here. In version 1, we don't have this. We don't. What we will put over here is simply like this. We'll say I is less than a.length minus 1, and then I plus plus. And over here we say is sorted, is assigned to, is sorted, whatever it is so far, conjunction with ai is less than or equal to I plus 1. Okay, now the thing for you to see in the first version is over here, right? You can see in the version number 1, we don't have any sophisticated state condition. We just have accumulation in the body of the loop. In the second version there, we don't have any accumulation over here. We don't. There's no conjunction here. Instead, we actually put the is sorted as part of the state condition. Okay, both versions work. Both versions. Okay, let's just try to see one example over there. Let's try to see that. Let's say I have an array like this. 0, 1, 2, 3, 4. So now A over here. So we know that a.length is 5. Okay. So now let's put some value over here. Let's say 3, 4, 4, 3, 6. Let's now think about the follow. Let me give you what about this example that would do. Okay. Now let's consider version 1 versus version 2. Version 1 here and version 2 here. I only want you to tell me about the return value should be obvious. For both cases, it should just be false. For both cases, right? Because A is not sorted. As you can see, in index 2, we got 4. In index 3, we got 3. It's not really decreasing, right? Oh, sorry, it's not really increasing. So that's not the case. Okay? It's not sorted. So now, my question is, for version 1, how many iterations would it take before we return the final result? How many iterations? And also for version 2, how many iterations? Okay, what about version 1? Be careful, how many iterations? I heard 4. Did you just say 5 before? Yeah, in the beginning. Would you agree it's 4? Did you say 5, or maybe I heard it wrong? Okay, but how many iterations would it take for version 1 to give you the result? You gotta go through, how many exactly iterations? I know I gotta go through the array, but how many iterations do I need? You think 5? Okay, 5 and 4, we'll see. Okay, 5 and 4. Okay, let's try to see version 1 and see exactly how many. For version 1 over here, I'm gonna use green over here. For version 1, when I is equal to 0, we are going to compare A 0 less than or equal to A 0 plus 1, which is 1, right? That's for version 1. And then when I is incremented to 1, we got A1 is less than or equal to A2, and etc. So what will be the last value for the loop counter in the last iteration? Would it be 4 or 5? Or even lower? Would it be 3 or 4 or 5? It should be 3, right? So now you can see that, etc. And then when I is equal to 3, that means we are saying A3 is less than or equal to A4. That means we're comparing exactly this one here. That'll be the last one. So how many iterations? 4. Remember the state condition over here is strictly less than a dot length minus 1. Okay, be careful. Okay, only 4 iterations. Okay. Again, you should really know why we didn't put as opposed to a dot length. Okay. We know that if you put a dot length over here, it's not going to work. You're going to get a array index out of bound exception. Okay, as I tried to illustrate in the previous slide. Okay, yeah. In the beginning of the question, what do you mean? A dot length minus 1, yeah. So you want me to explain again, or how should you know? You will try to well, let's say this is the first time you solve this problem over here. You definitely, even myself, I will put a dot length rather than a dot length minus 1. And then I'll realize, oh, why do I get this array index out of bound exception? It is because in the very last iteration, the value for counter I will be a dot length minus 1, exactly that. And then I plus 1 will give me a dot length, which is not a valid index for the array. So that's how I knew it. We're going to think backwards. So now since I know the result, I can tell you. But what if you don't know? You got to try and errors. Yeah. Okay, the version 1 is rather easy. What about version 2, guys? What about version 2? The version 2 is over here. Version 2 is over here. And the critical thing is, over here, we don't have accumulation in line number 3 anymore. There's no conjunction whatsoever. And then we put it sorted as part of the state condition over here. Now, same question again. How many iterations will we get? In version number 1, we got 4 iterations. That's a maximum. That means you're going to scan through basically everything until the second last elements. But what about version 2? Are we going to exit earlier? Yes, right? So now, can you tell me exactly how many iterations? 2 and 3? 3. But let's see why. Okay, it should be 3. So now you can see that basically in version number 2, you can think a bit more abstractly. As soon as you find out, as soon as the witness of violation is found, as soon as it is found, you exit. Let's see how. So now you can see that again. Let's see for version number 2, I'll put it here. For version number 2, I is going to be 0. When it is 0, we get A0 less than or equal to A1. Right? In this case, it is true because 3 is less than or equal to 4. And when it is 1, we get A1 less than or equal to A2. In that case, A1 less than or equal to A2, that's also true. So we go to the next iteration. Now, if I go over here, A2 less than or equal to A3, it's going to be false. 4 less than or equal to 3 is false. So that means over here, as soon as this is computed, is sorted, it's going to be assigned to false. And then what's going to happen is, as soon as this is false, we'll go back to the header of the loop and check for the state condition. And we know that it's sorted is just assigned to false. If one side of the if one side of the conjunction is false, doesn't matter what the other side is. So that will give us, that means it's going to be false, and then we exit. Okay? So that's why version 1 and version 2 are quite different. Okay? Okay, questions? Yes. you're trying to say, let me just make sure I understand you correctly, then I'll explain. You're trying to say, let's put another input array where it's really sorted.
No, that's not.
Okay, I'll just say that again.
Yes, so I'm saying, in the Boolean contents,
Yeah.
have this sorted equals AI,
Yeah.
I'm saying you make the iteration one less. If you put in what this sorted was and replace it with this sorted division. So if you say AI less or equal to AI plus 1,
Mm-hmm.
and then I is less or equal to A dot minus 1. And then you put and then this sorted would you just put through.
You know, I don't quite exactly follow your point. How about this? Speak to me again after class, and then I'll just convey that point to the class back. That'll be saving time. Just do call to me after class, okay? Yeah. Mhm. Because I don't want to answer something, you know, that's not really what you meant to ask. Okay. Okay, guys, any question about version 1 and 2? Yes. Oh, I mean version 1 versus version 2? Good question. So you can think about for version number 1. For version number 1 there, even though we already found the violation cases when I is equal to 3, to do version 2 as opposed to version 1? You mean? Oh, they would say it's sorted as, well, it's the same. So I think the question was as follows. Can you replace this line over here by something like this? Okay, so let's say this line over here, the body of the loop, you're trying to say something like this. You can say if it is, let's say AI larger than AI plus 1, right? That's a violation, right? And then over here, you can simply say it's sorted, it's assigned to false. That's what you meant, right? Yes, you can do that. Yes, logically speaking, they're the same. Yes. Very good. Okay. Okay, that's about it's sorted over here. You can also follow the tracing over here. I'll leave that to you. Okay. Okay, good. Yes. Okay, let's go a little bit further. It's sorted over here. Okay, just different example over here, so you can just follow through the same program. Okay, now let's just summarize. Okay, when you want to check the properties of the array, so you can either check to see if all the elements satisfy a property. That's the first category I just talked about in the beginning. In which case, you use conjunction. And then, as soon as you find out a violation witness, you can return false, right? Conceptually. As soon as you find out. If you cannot find any violation cases, you should return true. Okay, that one just reviewing. You can also go over these examples, the same. Now, let's say, okay, again, tracing. Okay, you can also follow the tracing. We have done all these, actually. Okay, now, another second kind of category is to say at least one element satisfy the property. In which case, we have to make sure as soon as we find out any witness of satisfaction which satisfy the property, we should return true as soon as we find out such a witness. Okay, and then we got to use disjunction. Okay, and also you can see that we use disjunction over here, and then we can also include as part of the state condition over here to say as long as we have not found such witness of satisfaction, we should keep going in the loop. Okay. Okay, that's also again the tracing for this second kind of problem over here. I can also leave them to you. Okay, so now observations. In general, if I give you a problem, what you want to determine is, do I really have to scan through the entire array? In some cases, you must do that. In some cases, you don't necessarily have to. So example for some cases. For example, if you want to calculate the maximum, the minimum, the total, in these problems, you must not skip any of the elements because it's not really something about logical property. It's just about I want to accumulate everything in the array and do something about it. In the case of the maximum, it could be that the maximum occurs in the last element in the array, in which case you should not skip anything, right? But in some other cases, you may want to exit as soon as you find out something that already tells you the result. For example, if I want to know if all the numbers are positive, as soon as I find out anything that's negative, I can return false right away. I don't need to bother. Similarly, if I want to know if there's at least one element that's positive, I can return true right away without bothering to scan even further. If I find out the first positive number, right? This is done. Okay, just go through the observation over here. Okay, so now compound loop. Okay, what I will do is I'll try to let's go through this example as well. I also got a source code for you in Android Studio. Okay, so this is more like a case study for some more complicated application. Okay, let's read the problem together. Well, it's not a complicated problem, but it's more complicated than what we said before. We want to read an integer from the user. We want to indicate, they want to indicate to see how many strings exactly they want to enter, and we want to prompt them that many strings and then print them out. What do I mean? Let's illustrate this. Okay, and now I'll show you the source code very quickly. The source code I'm going to post that online today, so you can also play with that. Okay, let's see. For this particular example, we got 4 versions of code to show you. Let's see one by one. Okay, this first version over here is very straightforward. Let's see what we should do. Okay, now you can see that the program simply asks you how many strings do you want to enter. So I'm going to say exactly what about 4 strings. So they would say enter the first string. I'll say what about A? Another string, second string, B, another string, C, another string, D, and then the program will just terminate it because I said 4, so that'll be exactly 4. If I say 5, you would allow me to enter 5. So now, can you imagine how you would implement this interactive program by yourself? Okay, think about that, but I will show you the source code very quickly, and then I'll highlight what you should really notice. Okay, let's go over the source code very quickly. Over here. So that's the source code. Okay, let's go over line by line. So we got 4 versions. So the first version, I'm going to go a little bit more details. Let's see very quickly. For line number 1, we just declare the scanner input. Line number 2, we prompt the user to see how many strings they want to enter. For line number 3, this is important. You might apply this pattern as well in your practice test. We say that we're going to ask the user how many strings they want to enter, how many. So it comes from the user, which can be 1 or 2 or 4, as I illustrated. And then this line over here is also important to say we're going to create an array of strings accordingly. You can see that over here, the how many over here corresponds to the how many over here. Right? That's important. You will need this kind of pattern a lot for your lab test too. Okay? So now after this, we can now exactly say, depending on how many is, if how many is 3, that means we're going to prompt the user for 3 times for the string. That means we're going to put the exit condition over here to be I is less than how many, right? That'll be 0, 1, and 2, for example, right? And 0, 1, 2, okay. Let me just give one example over here. If the how many over here is 4, so that means over here we're going to create an array of size 4. And then we're going to run the loop starting from 0 until I, as long as I is less than 4. That'll be 0, 1, 2, and 3, right? And then over here, we're going to, line number 6, we're going to prompt the user for another string. Okay, like that. And also read the next string. And then this line is also important over here. I'll just highlight that. Strings at position I is assigned to S, right? Whatever you read from the user, assign that to the particular position of the array. Okay? How about we see some run very quickly? Let's see this. Let's say, first of all, we say how many strings should there be. We say how many is simply just 4, let's say. And what we will do instead, what we'll do accordingly is we're going to create this strings array of size 4. 0, 1, 2, and 3. Okay? Initially, all the elements will point to just null. Initially. Okay? Initially. And then we're gonna go through this particular loop at line number 5, starting from there. And then there's a loop counter over here. I is initially just 0. Right? conceptually, you can think about I is pointing to over here. Now, if you have already started your tutorial background video for lab number 5, you have seen this pattern already. So I over here has two purposes. It tells you exactly how many strings have been stored so far, which is 0 at the moment. It also tells you what should be, where should you store the next string. Okay, so that's really from lab number 5. Okay, but you already want to use it. Okay, so I is equal to 0 to begin with. So now, when you say enter a string, let's say first time I enter A, right? So I'm going to store strings at position I, which is 0, and then I'll pass A over here, right? So that means for position 0, rather than pointing to null, you're going to point to A. Okay. Similarly, if we go back to the second iteration, I would now be 1. So conceptually, you can think about I is now pointing to the second position of the array, right? And now it will prompt you for another string in the iteration. Let's say we enter B in this case. In that case, we're going to say strings at position I, in this case, is 1. So we'll say at position 1 is assigned to B, right? So now rather than pointing to null, it's going to point to B, etc. What about the last iteration? In the last iteration, it would be, because we know that how many would just be 4. So that means the last value for the loop counter will be 3, right? So now in the last iteration, let's say we go C and we'll go D. For the last iteration, it will just be 3. Okay, and then we have D over here to store, and then we store that to D. Now, of course, before that, I also stored that to C. Right? That's exactly what I illustrated in the Android Studio. Okay, you should really try to study this code over here to get some more idea. Okay, I might change the code structure a little bit to test you what the corresponding behavior should be. Okay, so please make sure you understand what's going on here. Okay, any question about this one here before I extend it a little bit further? Yes. Yes. Oh, I see what you mean. So the question was, yes, good question. The question was, to really achieve the same result, what I could have done would be, I can say, let's say before the loop, I can simply say string, maybe I'll say result. Let's say empty string. And then every time when I do, I actually accumulate it by s plus equal the string. For this particular problem, yes. But in general, you may want to have an array of strings so that you can do some further processing later. But for this one here, I'm not really doing it. So I would say, if I only give you the problem like what I said in the slides, you can definitely solve it this way. That's no problem. But now here, what I want to show is a more general way of doing things. You may want to store all the strings you have read so far into some intermediate data structure, so you can do some further processing. Right? Right. Good. Good question. Okay, now, guys, let's now try to expand the problem a little bit further before I illustrate to you. Okay? Okay, that's exactly what I said. Okay. Now, second problem over here. Let's try to read it together. Before, if the user say, I will enter 4 strings, you really prompt them for 4 times. But now, we give the user a little bit of flexibility. We tell them that if you say 4, it doesn't really mean you're going to enter exactly 4 strings. You can enter up to 4, which means they might enter 0 string, they might enter 1, or 2, or 3, or 4. So giving them more flexibility. As soon as the user actually wants to exit from the program, they will say exit. Okay? So what do I mean by this? Let's say this over here. This is the expected run over here. So let's say how many strings, if I say 4, and then I enter Alan, I enter Mark, and then I don't want to enter anymore. I have a special indicator to say, now I want to exit. And then I say exit. And then they'll say, you have entered Alan and Mark. Okay? So even though the user says 4, that simply means the user can enter up to 4, but they don't have to enter exactly 4. So in the case where they enter less than 4, they want to exit, they'll say exit. And then for your program, you must enter exactly what they have entered so far. Okay? It's a little bit more flexible, which means more fun. Okay? I'm going to show you an extended version from the version number 1, I want you to think about if that version might work or not. If no, why? Okay, let's think about that. What I'll do is switch to iPad over here, and I'll illustrate to you on Android Studio in just a moment. Okay, so it's pretty much the same as before. I will show you exactly where the extension is. Okay, now for this one over here, we won't have a way to support to say if the user enters exit as a string, we want to exit from the loop. We don't want to prompt them any further as soon as they say exit. Okay, so one way to do it is in line number 4, I declare a Boolean variable over here to say user wants to continue, initially just true. As soon as they enter the string exit, I'm going to set this to be false. So how is this going to work? So whenever I want to use a Boolean variable to control the exit for the loop, put it as part of the state condition. That's why I put it here. You can see I simply say and user wants to continue over here. Initially, it will just be true. It's not going to make it false, right? But as soon as the user enters exit, we're going to make this Boolean variable false, which will cause the state condition false. So you can see over here, in line number 9, we have user wants to continue is going to be updated every time after the user has entered something. We want to check to see if the user just entered is exit. If it is exit, that means they want to exit. They don't want to continue, right? Okay, I will run one case for you in just a moment. And then we say that if the user does want to continue, then we'll do some assignments for the array. Okay? And then we say that after, let's just do some example right away. Okay? Let's say this. Let's say this is the console over here. Okay, first of all, the user say how many strings? The user say 4 strings, 4. Okay? So now that means how many over here will just be 4. Okay? And then the user wants to continue will just be true, no matter what. And then you can see that this, line number 5 over here, we're going to create again an array of strings. Okay, over here like that. 0, 1, 2, 3. Okay, initially all pointing to null, the default values. Okay, and now let's say enter a string. And let's say the user enter, for example, A. If they enter A, that means the S value will just be the string A. And then user wants to continue over here is going to be set to, okay, let's try to analyze this expression over here. We say not S dot equals exit. So we are comparing string values using dot equals. Now in this case, we know that S is simply just the string A. A dot equals will give you false. And false taking the negation will be true. That means the user, they do want to continue. Okay? So that means it will be true. Okay? So that means user wants to continue over here will just be true. And then if the user really wants to continue, in that case, we'll do this particular assignment over here. Right? Strings at position 0 is going to be assigned to A. So that means A. Okay? After this, we'll go back to the beginning of the array. Go back to the beginning of the loop. And then we know that how many is 4. And I has been incremented from 0 to 1. So 1 less than 4 is still true. But now, user wants to continue, as we learned from the previous run, is still true. So we got true and true. So that means go into the loop for one more time. So that means now we prompt the user for another string. Let's say this time the user say exit. They just want to print out one string only, just one. Okay? When they say exit over here, what's going to happen over here? When they say exit, that means the string over here is going to be exit for S. And then now for the same evaluation of this Boolean condition over here, what's that going to be? So now S is now exit. Exit dot equals exit will be true. And then we take the negation of that will be false. That means the user do not want to continue, right? So that means the user, they do not want to continue for the second iteration. Now, as soon as this is set to false over here, that means user wants to continue for the selection over here. We're not going to go into it. We don't really assign exit to be part of the string to be printed out. Okay? And then for false, when we go back to the beginning of the header over here, what's going to happen is user wants to continue right now is actually false, which will make the whole conjunction false. That means we don't enter the loop anymore. So that means we continue from line number 13. Okay? So the array of string looks like this. Okay? So now, what I want to ask you about is line number 13, 14, and 15 going to print out something that will make sense? The array looks like this, right? So now, how is line number 13, 14, and 15 going to print out? Is it just going to print out A or something else? It's going to print out whatever. How many elements would it print it out for line number 13, 14, and 15? How many elements? Huh? You certainly would print out A. Would it print out anything else? Huh? Everything. So what about at position 1? What's that? Oh, yeah, position, yeah, let me say index. At index 0 is A. What about index 1? Null. Okay, it's going to print out null, actually. Null is like a default value for object reference. Okay, let me just, you know what? It's said in the tutorial, but I'll just say it very quickly. So now, every time, for example, person, when you say person P at this point, okay, we are saying that, let's say person is a class that we declare, and P is a variable that's going to store the address of some person objects. By default, P does not store any objects, does not store any address, so it's going to be null. Null is like a default value, okay? Like something, if you don't initialize your reference variable, it just be null. Okay, let me illustrate this to you for this second version over here. So let me go back to Android Studio. Let me show you exactly what happened. So that'll be version 2. Okay, let me run it and show it to you. For version 2 over here, what we will have is like this. How many strings do we have? So now let's say we still say 4. Okay, if I say 4 strings, enter a string. If I simply say A, enter a second string, but I want to exit. Special indicator, and now what it will print out is you have entered A, null, null, null. A, and then it's going to print out A, null, null, null. So can you see what the problem is over here? Which line has caused this problem over here? Number 5? But the thing is, okay, your first intuition is about line number 5, because if you only want to actually get one element here, why don't you create an array of size 1? True, but somehow we want to give that flexibility to the user, so we never know how many exactly what they want to enter. That's why we allow them to enter exit when they want to stop. Initially, when they say 4, it simply tells you it will be up to 4 string they want to enter. But as soon as they want to stop, they will say exit. So you have no idea how many they want. It can be 0, can be 1, can be 2, can be 3, can be 4. So it turns out what's really problematic is over here. If you look at the state condition over here, we say the loop counter I is strictly less than strings.length. That means I is going to be of the values 0, 1, 2, and 3. So we are trying to print out even those values that have not been stored yet to the array, since we only read one string. Okay? That's the problem for the second version. Okay? But how can we resolve this? Yes? Exactly. So the solution is you got to keep a counter to say how many. So you can think about, that also relates to your lab number 5. So if you think about how many over here, think about this as the maximum capacity of your array, which is 0, 1, 2, and 3. But how many numbers the user actually enter is less than or equal to this, right? It can be 0, can be 1, can be 2, can be 3. So that means we need a separate counter to tell us exactly how many that have been entered. Okay? And then, let's say in this case, if we have only entered 1, in this case, that means the counter will just be 1. I'll put this counter in the next slide, version 3. That means when we put the exit condition over here, the state condition over here, the upper bound over here, rather than being the last rather than being the last index of the array, it should be this kind of counter. Okay, that's kind of intuitively how that works. But we'll see. Okay, that's why we go to the third version over here, version number 3. Okay, version number 3. How do we do that? Again, let's try to see exactly what's the extension. Okay, that would say version number 3. Version number 3 extended from version number 2. Version number 2 was almost correct. Okay, so this is version number 2, right? Okay. Now for version number 3, let's see exactly what the extensions are. So now let's go to our let's to the annotates. First of all, as you said before, we are going to declare some counter over here to tell us exactly the numbers of string being entered by the user. So that's in line number 6. We're going to keep the counter starting from 0. Okay, now how do we increment the counter? Every time when you are trying to, you can see that this is where we actually try to put a string into the array. Every time you say that, you're going to increment the counter by 1 every time. Okay? So what does that mean? Let's just do very quickly. Again, let's talk about the same array over here, strings. Okay? Let's say how many in this case is just 4. Okay? 0, 1, 2, and 3. And the number of strings read is initially 0 over here. Okay? So now for the very first iteration, let's say we read A from the user. In that case, when we try to say strings I is assigned to S, we are basically doing strings at position 0 is assigned to S over here, which is A. That means A is over here. At the same time, we are also trying to increment the number of strings being read, which is going to be 0 and then to 1. What does 1 over here mean? That means we have so far accumulated 1 string in the array. And if you want to store the next one, you better store it in index 1. Okay? So let's say we do another one. Let's say we do another line called B. Okay? In this case, when we try to go to line number 12 again, so what we will do is we'll say strings at position 1 is assigned to B because the counter has been incremented. So this will be pointing to B. And then we also got to increment the number of string being read over here. So that'll be 2. Okay. So now let's say we got 2 strings so far. And when we want to print out the array, we want to print out only A and B, not A, B, no. That's not what we want to do. So what we should do is, you can see that over here, the main extension over here is, we say that I is less than number of strings read. You can see that we are trying to specify the upper bounds for the counter rather than strings.length. We're saying it's strictly less than the number of strings read, right? So now what's that value over there at the moment? It's 2. That means I is less than 2 will be the actual state condition for that. So that means I will only be running 0 and 1 rather than 0, 1, 2, 3, right? So that means we only printing out A and B accordingly. So we don't print out anything that's not there yet. Okay? Okay, so if you try to go back to the Android Studio, let's try this third version over here. The third version over here is going to work. Okay, let's see that. How many strings? Let's say 4 strings we have. Let's say A and then B, and then we want to exit. We don't want to enter anymore. You have entered A and B rather than A, B, now. So far we have covered 3 versions up to now, right? Guys, any questions so far? It's quite a, yeah. The question was, you can see over here, okay. The question was like this. let's have a look at this line over here. You can see that over here, line number 10, we are trying to update user wants to continue over here before we try to do this. Your question was, what if you swap the order? No, it wouldn't work. It would take, the reason that it wouldn't work is, conceptually speaking, we want to check to see S over here is the latest value you read from the user. You want to check to see, first of all, if the user want to exit. If they want to exit, that means you don't want to store the current S into the array. Otherwise, you're going to store it. But if you swap the order of these two lines, let's say line number 10 and line number 11, if you swap them, that means you will try to store into the array according to the user's previous intention, not the latest one. You see what I mean? Yeah, you might want to do something like that, but I would say that's a little bit less intuitive, right? Yeah, questions?
How do we manage to prevent from seeing that null string? Because we saw that in version 2 of this compound. How do we manage to avoid?
Yep, so the question was, how do we, in this version number 3, how do we manage to actually avoid printing null over here, right, in these two positions? The key is really this counter over here. This is really the counter. Because this separate counter over here, which tells you how many strings we have read so far from the user, which can be 0, which can be 1, can be 2, can be 3, can be 4, up to how many, right? So now in this case, if we simply put number of strings over here, that means if the number of strings is actually 2, in this case, we got 1 string and 2 string. That means conceptually, number of string is pointing to here, right? Conceptually. In that case, we only go, but not including this particular position, which is null. That means we only print out these two. So the key is really here. We use the counter over here as the upper bound for the loop counter. Make sense to you?
Because we have to, because I guess once we pass through those counters in the array, I guess that's the number of strings that was completed. So I guess that's how we avoided the null in this case.
No. Okay, if you still got some confusion, let me just draw some summary over here quickly. Okay, let's see this. So first of all, for this particular example, first of all, we read how many from the user. Let's say it is 4. That means accordingly, we create an array of size 4. 0, 1, 2, 3. Okay? Initially, just all pointing to null. Okay? And then we also have a separate counter called the number of strings. Okay, like here, right? The number of strings over here. Initially, the value is just 0, which means no string have been read so far, okay, from the user. And now, every time, if you try to read a new string from the user and store into the array, we're going to increment the counter by 1. So after the very first string, the counter will be incremented from 0 to 1. The 1 over here means, so 1 string read so far. And also store the next string at index 1. Okay, let's do another one. What about we read another string from the user? Let's say we read B. If we do that, that means the number of string is going to be incremented from 1 to 2. So 2 now means 2 strings being read so far. And also for the next string, you want to store that at index 2. Okay, that means over here, the third string. Okay, so now the trick, back to your original question. So over here, this is really the main thing to make sure you only print up to where you store, right? You can see now, for now, you got A and B, and all the other slots are simply just null. So you can see this is null, this is also null. So now when you say the following, when you say for integer I is assigned to 0, I is less than the number of strings, I'll just say number of strings, and then I plus plus. And then if you say print line over here, you will just say strings at position I. So what does that mean? In this case, we know that the number of strings over here is exactly this, which is 2. Right? Rather than if you simply put strings.length, which is 4, that means you will also go through these 2 slots, which is not right. So this is really the key to make it work. Okay? Guys, make sense? Okay? You may want to watch the recording again to make sure I go through that. I know it's a tricky example, that's why so many versions to worry about. Yet another version. Yet another one. So version 3 works. I want to show you another version that also works, but in a way that's logically equivalent. Okay? Okay, I'll briefly mention that, and then I'll leave the struggling to you. You should really also try to study that. Okay? So now in version number 3, the logical variable that we declare was over here. Boolean, user wants to continue is true. Okay? Now, I want to think in some way that's going to work exactly the same way, but logically equivalent. Rather than thinking about when does the user wants to continue, let's think about when the user wants to exit. Okay? So what does it really mean when the user wants to exit? As soon as they enter a string called exit, right? So now in this 4th version over here, which works, we're going to declare a Boolean variable over here. User wants to exit. And initially it's false. We assume that the user does want to do something. So initially that should be false. They don't want to exit just yet. As opposed to the user wants to continue over here is true, right? It's kind of the opposite, the negation of each other. And now let's see how other things might change. Now what about the state condition over here? We say that over here, this is the state condition for the loop. We say that we're going to keep prompting the user for more strings as long as I is still valid, and also the user do not want to exit. So this means user over here does not want to exit. So the not, how do I see the not? Is exactly this exclamation mark over here. Okay? And then how do we update user want to exit? The way we did it in the version number 3, we say that s.equals exit and then put a negation point, right? So now in this version number 4, we don't put that negation point anymore. We simply say user wants to exit if the string they enter is just exit, okay? And then we say if the user don't want to exit, then we can sort the string inside the array, okay? This version here is completely equivalent to the version number 3, okay? Complete equivalence. Let's just see one run very quickly. Again, this is the console over here. Let's say the user say how many? They say 4. Okay, doesn't matter. And now, initially, user want to exit would be false over here. And then, user want to exit initially is false. Not false would be true initially. So we go into read the very first string. And let's say the user enter, let's say A over here. Okay, so you can see that when we want to see if the user wants to exit, S over here is just A. A.equals exit would be false. False means the user do not want to exit. Since they don't want to exit, so when we say if not user want to exit, that would be just true. Since they don't want to exit, so we'll just keep going with reading the string. Okay, let's go to the second iteration there. When we go back there, the user want to exit is still false. Okay, so that means not false will be true. Second iteration. Let's say the user this time enter exit. Now, what's going to happen? If they enter exit, that means s.equals exit. In this case, s will be exit. Exit.equals exit will be true. In that case, if not true will be false. That means we bypass these 2 lines. So we don't really enter, we don't really store the exit into the array anymore. So when we go back to the header of the loop over here, so now we know that user wants to exit will be true already. And not true will give us false. And then we exit from the loop, right? It works exactly the same way. It's just that the way we use the logical variable over here is different, but they're completely equivalent, okay? So for this particular example, I gave you 4 versions. I expect you to know all of them, okay? Please, okay? How much time do we have? 10 minutes, okay? So now let me just go a little bit further over here to talk about, it's something about short circuit, okay? So maybe we'll talk about two-dimensional array next Monday. Hopefully the strike is over already, I hope. Okay, but let's now talk about another example, okay? Okay, so that's the 4 versions we talked about in very much details. And now let's go back here. Let's now think about this. And we thoroughly covered the short circuit logic for conjunction and disjunction last time. And then we use the short circuit to avoid null pointer exception and also the division by 0 exception. We're going to see another case study for the short circuit. Okay? Again, ask the user how many integers they would like to input, and then we want to get exactly one of them and check to see if the number is even or not. Okay? So now, let's see how exactly we can do that. Let me give you one example over here. So if you go to the code example there, I also got a code example for you. It's called short circuit array access. Okay, let me just run that and then illustrate to you. Okay, so now over here, okay, how many integers? If I say 4 integers, okay, I'm going to enter exactly 4 integers. Let's make it easy. Just 1, 2, 3, 4. 1, 2, 3, and 4. Now, the program prompts me for the index for the underlying array. If you imagine in your mind, since the user say they're going to enter 4 integers, underlined under the hood, there's an array of size 4. Indices should be 0, 1, 2, 3, right? If I simply say index 0 over here is valid, so it's going to return to me the elements at index 0. If I say 1 over here, it's going to return the elements at index 1. It's that easy, okay? Let me say if I put 2 over here, it's going to return to me 3, which is not even. Element at index 2 is not even, right? Given that I give it a valid index. Now, let's look at the code. And then let's think about what can crash. This is a code over here, okay? Again, you can see that it's very standard of writing the code. Declare the scanner, prompt the user for how many integers, and read how many integers there might be, and also initialize an array accordingly. Sorry, not this line. Initialize the array of this large size accordingly, and then we're gonna every time we're gonna just put the element into the array. And now, what's really going to be interesting is this particular line. Line number 9, we ask the user to give us an index. Okay, and now in line number 10, we say that whatever the user enter as the index I, and then we're going to use it to access the array. Okay, that's what we have. So now, for example, if the user actually say how many, if they say 4, so that means we got numbers which points to an array of size 4. Okay, and then let's say we just do what I did before. I'm just going to enter the values for each one of them. So got 1, 2, 3, and 4. Okay, and then we'll prompt the user enter an integer index, right? If we simply say, for example, some valid case, if I say I can be, let's say if I say 0. Oh, sorry, not this, not here. Let me do it again. Enter an index over here, okay? That's what we prompt the user to do. And then let's say if we simply say 0, that is valid. That means we return this particular elements in the array, right? Similarly, if we say 3 over here, then we return this particular elements, right? Now, can you see any danger for this particular program over here? Does it work always? No. Give me one value that wouldn't work. Huh? 10. Yeah, for example, if you say I is 10, if I is 10, for example, you'll simply take I verbatim to access into the array. That's not valid, right? So now, what we can do instead is to somehow use the short circuit effects that we talked about from last time, okay? What we will do is, I'm going to annotate this to you right away. Okay, over here, what we can do, there are two different ways to do it, two different ways. One way is using conjunction. I can say, first of all, for any array index to be valid, it must be large enough, and also it must be small enough, right? What is to be large enough? So 0 less than or equal to I, and I less than or equal to ns dot length minus 1. And I say n%, and then ns at position I modulo 2 is 0. This is going to protect it because, now let's go back to your example for 10. If I got 10 over here, so if I is actually 10 larger than or equal to 0, true. So that means the left, so that means we'll go ahead and evaluate the next one. So now 10 less than or equal to ns.length minus 1 is going to be false. So that means we'll stop there. Don't even go further. Okay? That's a short circuit. Now, question for you. If I swap the order a little bit, tell me if that might fail. Let me give you another version. Let's say I less than or equal to ns.length minus 1 and 0, okay, not here, and then ns at position I modulo 2 equals 0 and 0 less than or equal to I. The red version, is the red version going to work? Always. Is it going to work always? If you don't think it's going to work always, give me a witness. Give me a witness of I, which is going to crash the program. Let's think about your original example, 10. Is it going to work? If it say 10. If we got the original example for 10, let's say we got 10 over here. So now 10 less than or equal to ns length minus 1, which will give us false, which means we still don't go evaluating further. So that one will be okay. So now, can you give me one value that is going to make the program crash? Minus 1, thank you. If we got minus 1 over here, that means for minus 1, so now, minus 1 less than or equal to ns.length minus 1, true, right? Because ns.length minus 1 would be 3. Minus 1 less than or equal to 3, true. So that means we'll still go into this program over here and then go for ns at position minus 1. It's going to crash. So you can see that for this short circuit to work, the order of execution really matters. Okay, guys, any questions? Short circuit. If you're still not sure about what short circuit is, it's really important to learn Java. So you should really review the lecture last Monday. Okay? Did you come to the lecture last time? You didn't? Yeah. Let me briefly mention, but you can watch the recording. How about that? Okay? Very briefly. Rather you ask me now rather than after the exam, right? Okay, good. Okay, now let's just try to do this very quickly. Short circuit, let's evaluate that, review that very quickly. Okay, so we got something called short circuit. So now when you got expression E1 and expression E2. So this can be any arbitrary expression, this can be any arbitrary expression, right? So now the way we evaluate at the runtime is go from left to right. So now, for the case of the conjunction, we know that if I already know E1 is false, logically speaking, it doesn't really matter what E2 is, right? It will be false anyway. So at the runtime, the short circuit effect is, if we know that E1 is already false, we don't bother to go ahead to evaluate the right-hand side. So now in this case, you can think about E1 is pretty much like, let's think about this one here, okay? So E1 is pretty much like this. This is like an E1. If this is already false, then we don't bother to go ahead to evaluate the middle one. If the middle one is already false, we don't bother to evaluate the rightmost one, left to right. Okay, short circuit, very briefly. And symmetric speaking, you also got E1 or E2. If we know already that this is already true, then we don't bother to evaluate the right-hand side. because it's guaranteed to be true. Okay, that short circuit effect is really important. Okay, really important. Okay. Yeah. Make sense to you? The order. The reason is, if you compare this version here and second version over here, first of all, let's agree the order of execution will be different, right? For the first version, let me just use different color. How about that? Let's say for version 1, we first evaluate this, and then we evaluate this, and then we evaluate that. So that's the order of execution, right? For the second version there, also from left to right, first evaluate this, second evaluate this, and third evaluate that. Okay? Now, let's say we take your original example, let's say for 10. Okay? No, minus 1. How about that? Minus 1. Let's think about I being minus 1. Okay? Now, for version 1 and 2, we're going to evaluate this and this respectively, right? Okay? So now, 0 less than or equal to minus 1 would be false already. So that means we don't bother to evaluate the rest. But in the second version there, minus 1 less than or equal to ns that length minus 1, true, right? So that would be true. If it is true, we have to evaluate the right-hand side. So that means you will you will go to this expression here, evaluate it, you'll crash. See it? Yeah. Yeah, so you really got to see exactly the order of execution and to see if that's false for the conjunction or true for the disjunction. Yeah. So guys, before I let you go, I know I'm running a little bit over time. Bear with me 1 minute. I would like you to read over until here. Okay. So now this is exactly what I said. Try to read it over the slide very carefully. I enumerated all the possible cases for you. Okay. So now over here. So now, over here, I want you to review up to this case. You can see that when you got different order of evaluation, what will be the crashing condition and what will be the non-crashing condition, right? Exactly how I review. So now in this case over here, I'm simply putting the expression that is supposed to be guarded at front. That means it will be evaluated at first anyway. So that means these two guarding conditions over here doesn't really help. They will only be evaluated when the one you want to protect already crashed, right? And then if I change one of them to be before that, and it might still crash, okay? If I change one of them to be over here, it might still crash, but the condition will be different. I want you to evaluate this slide, this slide very carefully. Okay, so slide 60 would be what you should review up to. Okay, so what's going to happen next Monday, regardless of any strike? I'm going to finish the arrays for short and loops, and then we go into two-dimensional array. And then I'll release your lab number 6 next Friday. So you can also start with that. Okay? Any question for me before I let you go? Okay, let me stop the recording over here.